Hi, this is Alex from devstories.eu. Astropy, Python for Astronomy, Episode 7 of 15. You have an old, messy text file of star coordinates, and you need to convert it into a modern, compressed binary standard. In most libraries, that means writing a custom parser, mapping data types, and fighting with binary serializers. In Astropy, you can accomplish this with exactly 2 lines of code. This is thanks to the Unified I/O interface. The Unified I/O interface is a polymorphic data handling layer. Instead of forcing you to import a specific module for every file type, Astropy exposes a generic read and write method directly on its core data structures. Whether you were dealing with a standard table, a Q table with physical units, or a multidimensional ND data array, the interaction model remains identical across entirely different file standards. There is a common misconception about extracting data. When developers need to read a FITS file, they often go straight for the low-level module, astropy.io.fits. That module is strictly for raw file manipulation, like editing individual header cards or inspecting unformatted byte streams. If you just want to extract tabular data from a FITS file, you should not use it. You use the table.read method instead. It bypasses the manual header extraction and handles the underlying data mapping automatically. When you call the read method and pass a file path or an open file object, Astropy relies on a robust format inference engine. First, it checks the file extension. If you provide a string ending in .h5 or .parquet, it routes the request to the corresponding specialized parser. If the extension is ambiguous, missing, or just a generic text extension, the engine drops down a level and inspects the file contents. It reads the first few bytes of the data, looking for known signatures or magic numbers to reliably identify the standard. If the automatic inference fails completely, you bypass it by passing a format argument string, like ASCII.csv, to force the correct parser. Here is how this handles our initial scenario. You have that old ASCII text table of star coordinates. You call qtable.read and pass it your text file path. Astropy detects the ASCII format, parses the columns, and returns a fully populated qtable object in memory. Next, you want to save this as a compressed FITS binary table. You take that same qtable object in memory and call its write method. You provide a new file name ending in .fits, and you pass an extra parameter to enable compression. You must also pass an overwrite flag set to true because the write method safely protects existing files by default. This is where it gets interesting. Astropy dynamically switches context from plain text parsing to complex binary serialization under the hood. The underlying file protocols are completely distinct, but the interface you use remains unchanged. Because the interface is attached to the data structure rather than the file format, your data processing pipelines become decoupled from your storage mediums. The single most useful takeaway here is that changing how your application stores and shares data requires altering a file extension in a single string, rather than rewriting your entire data ingestion pipeline. That's it for today. Thanks for listening. Go build something cool.